Good evening, everyone. Thanks for having us here. So I'm Guillaume Laforge. I'm working for Google in the Google Cloud Platform team, and here is
Audrey Neveu. Thanks for the
working
introduction.
for
Streamdata.io.
And we are going to be speaking about web APIs and how to make those web APIs more scalable and more real-time.
Yeah.
All right. And I'm a bit tired. Who is binge streaming like Netflix, for example? Are there some Netflix?
Few of them.
Because I thought about another joke to make, like the binge, you know, the potato. Never mind. Okay, so two parts in this presentation. The first presentation is going to be introducing you to Google Cloud Endpoints on the Google Cloud Platform, which is how I'm going to develop and deploy and monitor and manage my web API. And then we'll add another layer, the real-time layer, thanks to the Streamdata.io technology. So, Google Cloud Endpoints. There was a first version of Endpoints years ago, but there's a new version still called Cloud Endpoints. But the first version was really just about Google App Engine and using Java and Python. But what's interesting with this new version of Google Cloud Endpoints is that you can use any language, any framework, any tech stack, or even any cloud. Although I'm going to use Google Cloud Platform, you could also use Google Cloud Endpoints to manage an existing API on-prem, in another cloud, etc. So here I'm going to use Cloud Endpoints, and the implementation of my API is going to be running inside App Engine Flex. There are two flavors of App Engine. And I'm going to show you the code a little bit later on. But it's a Ratpack application. Anyone knows about the Ratpack framework or library? Yeah, a few hands. And I'm using Groovy because I wear sometimes my Groovy hat as well.
Because you have to.
Yeah, I have to. Yeah. Okay. So in terms of compute options on the cloud platform, there are mainly three options. So there's App Engine, which is here. So two flavors, Standard and Flex. Standard, that's the usual Java and Python version. But Flex, it's more or less, you can even create your own Docker containers. And so if you want to use any tech, any framework, any language, you can easily do that. What's nice with App Engine is that in terms of scaling, it scales for you. So you don't have, you really just focus on your code, you focus on your application, you don't have to focus on the DevOps aspects of scaling. So it's really pretty much free. But you've got the knobs that you can tweak if you want to customize the scaling. The other option is Container Engine, so it's based on Kubernetes. There was a great talk earlier at university about that, where you basically cluster containers, whether it's Docker or other technologies, Rocket, etc. And the last one, that's Compute Engine, where you have full control. So you've got your VMs, you can customize your VMs, even at the OS level. So it's up to you. But for this presentation, I'm going to focus on using App Engine instead. So API management, quick definition of API management taken from, if you type API management on Google search, you're going to see something like this. So API management, that's really the process of publishing, documenting, overseeing APIs in a secure and scalable environment. So those points are interesting. And basically, Cloud Endpoints is Google's own solution for API management. And if you're developing and publishing and scaling an API on Google Cloud Endpoint and the cloud infrastructure, it's actually the very same architecture which serves, all the APIs that you know from Google. So let's say, Google Maps or any other API that you might have been using. It's really using the same underlying architecture. What's interesting with this new version of Cloud Endpoints is the fact that it's using open API specs, so it's formerly known as Swagger, perhaps. Who's familiar with Swagger? Yeah, great. And so often people still speak about Swagger, but the new name is Open API Spec under the Linux initiative, which is standardizing the Swagger format. So here I'm going to show an API built with REST API using JSON over HTTP, but it works as well with gRPC. What's interesting with Swagger or Open API specs, so usually you tend to work with, it's not mandatory, but you usually work that way, in contract-first approach. So you design the contract, and then different stakeholders, so perhaps those who are designing the contract of the APIs may be different from those who are actually implementing the API, and you are able to base all your discussions, team collaboration, etc., on this contract. Often in the Java world, you would use code generation, annotations, and things like that to generate a contract after the fact. But here, the good practice would be to use a contract-first approach. What's also interesting with the fact of basing your APIs on an API definition format is that since it's already a standard which is quite well known and used by many developers, is that it's great for tooling. So you've got one particular standard and format which has been used by tools to do things like generating client kits, so APIs to, let's say, programs to call your API, server skeletons. If you want to implement an empty API, then you fill in the gaps to add the business logic. But you can also generate mocks or stubs, create some playgrounds where you can interact with the API. That's the Swagger UI is a good example of that. And also generate documentation. Sorry. In terms of API management, there are three key important aspects, regardless of how you're going to deploy or develop, I would say develop your API, if it's for a public API, an internal API, etc. Three key aspects: security, so you want to authenticate your users. Endpoints provides different hooks for authentication, like the Google authentication or JSON Web Tokens and other authentication mechanisms. What you're going to be interested in as well is monitoring. You want to see, okay, who called my API, how many calls did I get on that particular method, endpoint, etc., and gather some key metrics and potentially set up some alerts. So if you see, okay, there are quite a bunch of errors being reported for when users are calling, the consumers are calling my API. And the last aspect, the scalability, which is brought, I would say, by the where you actually deploy your API. Here I'm going to deploy that on the Google Cloud, but you can, with Cloud Endpoints, deploy elsewhere as well. In terms of speed in particular, that's the architecture, but I'm going to explain that here. So you've got consumers calling your API, but they are actually routed through the ESP, the Extensible Service Proxy. So it's a container that runs along your API. And if you're in an environment like on App Engine, for example, where automatically the auto-scaling might spin off additional versions of, not versions, but instances of your API, then you're going to have a proxy per instance. So the proxy is always as close as possible to the code of your API. So there's basically no latency, because otherwise, sometimes when you use a third-party API management solution, you have to go through the proxy and then go back to the app, or you might have a big central proxy that delegates to tons of different APIs. So here you actually have one small lightweight proxy for your API and per, let's say, instance of your API. So very low latency. This proxy is based on Nginx. It will actually be open source. So it's fairly thin, and the latency aspect is pretty important. So let's have a look at the demo. So here we are at Devox, and Devox provides an API. So we were inspired by this API, and we reused the content of the API for our demo. So it's an API that's going to allow you to look up the schedule, the speakers, the talks, etc. And for that, so it's certainly a bit small. Whoops, perhaps a bit too big now. Can't find the middle ground. Okay. Where shall I say? So this is just the build script, so it's not very interesting. But here I'm using Ratpack. So it's a nice toolkit for developing asynchronous apps, not just asynchronous, but asynchronous apps. It works pretty well for that use case. You define handlers for the different path of your API. So for example, I've got an API /talk, an API prefix with a get method. Or perhaps I should show you actually first the Swagger file where you can see the path more easily. So I define the contract of my API. So I've got /import to import the dump of the available talks. You've got API to get the list of all the talks available. You can have a look at the details of one particular talk. You can vote for a talk as well, as we shall see. And you can also see the schedule per day. And so this is a Swagger definition. So you see the different paths. You see, for example, let's have a look. Let's say, no, this one, the import. I'm in input. I consume some JSON content because I exported the content of the API as a JSON file. So I'm consuming this payload, and in return, I'm returning some kind of result, which is here and there as well, depending on the case. And the case, if it works, I get a status code 200. If it doesn't work, I get a 400 status code. And this is, basically what the Swagger file looks like. So I've coded the application there, but it doesn't really matter the technology I've used. You can use whichever you want. Then, because I'm using App Engine Flex, I can define my own custom Docker container. So it's based on OpenJDK 8. That's a requirement for Ratpack, which is based on JDK 8. And I've built a distribution of my application, and then my entry point, that the startup script, basically, for my app. And here, I'm going to increase the font size as well. Okay, and then I've deployed that on the command line, and then I can call my API. So it's not very beautiful. I'm going to use a little tool. I don't know if you know about it. It's called JQ. And it's going to format things nicely. So that's the list of all the talks. Okay, I can show you like all the talks just on Monday. And you'll see, there's Monday right there. You can see one particular talk, which is, where's my cursor? It's there. So here I can see a talk, and I can also vote for a talk with a post request. So let's say I'm going to vote, give a positive vote on that one, and I'm going to see that there's an additional positive vote right here. And just one last minute to show you what it looks like in the console on the Google Cloud Platform console. So I'm going to increase the font size as well. So this is my App Engine application. I've got just one instance because there's not much traffic there, but there's a new tab here for the endpoints. So this is my API, some graphs, and I can also see, did I click? I think so. and I can see some additional details. So I can share the API through the API catalog, and it should be showing up, yeah. So here's the traffic, the errors I get, the total latency. You can see the various methods which have been called, the various endpoints which have been called on your API. And I could scale this API because it's scaling well on Google Cloud Platform, but in order to make things more real-time, there are some additional benefits to using Stream.io, which allows you to scale an API quite nicely. So now this is Audrey's turn.
Thank you. So, now that we've got those shiny new APIs, we would like to consume them in perhaps a mobile application or web application. So I decided to code it mine, which I've made with Polymer, which is a component-oriented framework. So it looks like this. As you can see, I'm a very good CSS developer, actually. Perhaps I should have been attending the other talk on Flex. Too late. So this application is pretty fine. The only problem is at the moment, if I want to have the last number of reactions on a talk, I have to hit the refresh button. That's not really cool. That's not what users are expecting from us. Because they expect to have real-time user experience. If you have a look at successful apps at the moment, they are completely based on real-time. Some of them are completely, the experience is entirely based on real-time. That's the case, for example, of Uber. I mean, when you're seeing your driver arriving. And so I take here as example Twitter and WhatsApp, but I could have mentioned Waze or Slack or Google Drive. So really, it's something users expect from us. They don't want to read the refresh button anymore. So talking about solutions for real-time application, usually polling is mentioned. I guess a lot of you knows polling. I don't really see you, but yeah, a lot of. Okay, so I bet you will probably not very happy, Guillaume, if I mean, 3,500 persons start polling your APIs.
Yeah, because currently my API is just using in-memory, one instance on an in-memory structure. So if there's a new instance coming up, I won't have the same data. I didn't scale, although I have the platform that scales, I didn't scale it.
And it will have a big cost on the outgoing traffic, because polling is making a request, waiting for the answer, making the same request, waiting for the answer, and so on and so forth. So the thing is, you will probably make a lot of useless calls. You will retrieve perhaps empty responses. You will retrieve the same response a few times. And obviously, how are you going to deal with connection lost? Because when we are talking about streaming, we have to take care of what's happened if the connection is dropped for any reason. So polling and long polling is not a solution. Obviously, we can make WebSockets. That works pretty fine. It's bidirectional. It supports binary. It means that it's a little bit of engineering for our use case, because the only request we are going to make from the client to the server can be easily handled by a post request, a classic one. And, well, we are not going to send binary, aren't we? No, I don't think so. So, what if I'm asking you to reconfigure your proxy?
What?
Yeah, because the funny thing with WebSocket is that it has its own protocol, a TCP-based protocol, which does not rely on HTTP anymore, which means that you have to reconfigure your proxy and load balancer, and usually it's quite tricky to make properly. So it's definitely not solutions for our use case. The solutions we are going to keep is service-sent events. I don't know if a lot of you knows about service-sent events. Yeah, it's attending my talk, so you're cheating. If you want to know more deeply about server sentiments, I made a tools in action tomorrow to see the difference between WebSockets and server sentiments. So server sentiments basically allows to start a streaming connection between the server and the client so that the server can push data as they happens to the client. It only handles text, but for our use case, it's absolutely perfect. And the good thing is it completely relies on HTTP, so you don't have to make any changes.
Nice.
But I'm pretty sure you don't want to change your code.
Why would I?
Yeah, you're right, because it's not your business real time, so it's
I'm
for
just
the front.
working on the back end.
Okay, great.
Take care of the front.
So that's the reason why we've created streamdata.io. So streamdata.io is a proxy available in SaaS mode, which completely relies on server sentiments. So basically, we are going to make the polling for you. We are going to deal with empty responses and all that kind of stuff and connection lost. And we added a few features to make it still better and more efficient. So for example, we added a dynamic cache, which means that if the applications became very popular and some persons are joining the session, they don't have to wait until the next poll to retrieve data. They can just have it from the cache. And we added incremental updates with the help of JSON patch. So it means that, let's imagine that on the first pull request, we retrieve some data. And on the second pull request, nothing has changed. We will not push you any data, it has no sense. But if on the third pull request, only a few changes, a few fields have changed, we will use JSON patch. So JSON patch defines a set of operations which can be applied to a JSON document. So we get, for example, replace, move, delete, that kind of stuff. So if we imagine that this is the snapshot we received on the first call and that only 2 fields have changed, on the third call you will retrieve this instead of the whole document again. And then you can simply use the JSON patch library to apply this patch to your document and so not reload it again. So you significantly reduce the amount of data exchange between the server and the client. So now let's see how it works. So basically, to start a streaming session, I just need to go to the proxy. Well, zoom a little bit. Yeah, perhaps too much. And I'm going to create a new app. Let's call it demo, for example. So once my application is created, a token has been generated, which is related to my application. And I can copy-paste the API I want to stream there to test it. So here I'm going to keep this API, which is one of ours. It simulates a stock API. So I can copy-paste the curl command there to see what it looks like in a terminal. I'm going to make it, oops, that's not that. Okay, so here I receive my first snapshot of data. It's the event called data. And then I receive the second snapshot. So once this is done, I can go back to the My API section, which should be there. And then I can change the polling frequency. So let's say, for example, that I would like to poll this API every second because it's stock values, so it has sense to pull it every second. And although if you get HTTP headers or query parameters, obviously you can add them there. And if I'm going back on the terminal, I can see that the update frequency has been updated, the polling frequency has been updated without closing and reopening the street, which is pretty cool. So, fine, let's see how it looks like in the code. So that's the application. You didn't mention it, but quite important, it's not the true vote API. It's not linked to it, just our own. And I made a few tests on the first one, as you can see. So if I click there, at the moment it's making an AJAX request to load the list of talk for Tuesdays, and then I can go on the talk, and it's the same. It's completely bind on AJAX request. And if I'm voting there, for example, so 2 requests are made, one for vote, and one to update the content. So that's not really good, especially because if you, at the same moment, were looking at the list of talks, you will not have this update. So we're going to see how we can turn it into a streamed API. So here I've created a streamdata.io component, which I will release on open source after Devox, just time for me to make a few documentation with. And so this component relies on our JavaScript SDK, which you can use in any front-end applications, and it's available on NPM. And here is my talk details object. So here I got few CSS. Well, I've done my best. I know it's not that great, but I've done my best. A few HTML component. I'm not going to enter into details. Here, my paper icon button to vote. And there, you can see my list of requests. So the request, which is called when I vote, is this one, talk details request. So I'm just going to delete it and replace it with my streamdata.io component.
You're fast.
Yeah, I know, I know. And as you can see, so I'm giving the token which has been given to me by the portal. I'm giving the URL. I'm giving the APIs, the path. So the path is separated from the URL so that the streaming session is able to handle path changes. If, for example, I don't want to see talks on Monday anymore, but Tuesday, it can update. I can handle both object and arrays in this component, so you just have to precise it there. And an isActive component to close the streaming session if you're leaving the page. And then I will have two handlers to add to this component, on snapshot and on patch. And so we are going to delete the useless code, this one too. And we are going to add our onData method, which will give us the first snapshot of data. So here I'm just calling, it's an event which is fired, so I'm calling snapshot.detail.data, and I'm retrieving my snapshot and make a few treatments like assigning the icon, etc. And then I can simply add an onData handler. So here it's quite ugly, but it's not my fault, I have to say. Polymer, in its first version, is making dirty checking, which means that it will not look in the object properties to see changes. It will only look at the reference, and so it will not be able, to deal with the changes. So that's the reason why we have to make this this trick. Oh, I've pasted on snapshot 2 times. That's not what I was looking for. Okay, I don't have onData anymore. That's interesting. What if I'm doing that? Okay, so I'm gonna see if I can just pick it from there. Yeah, it's on patch. So here it is. So basically, we are just saving the values, assigning an empty values, and then reassign the values again. That's quite ugly, but that will be fixed in version 2. That's the good news. And so if we are going back there, and I think we can. So here I received my first snapshot. If I'm just voting there, I received a patch event, and my talk has been updated. And so that's it for the demo. We got still 1 minute left if you got questions.
Yeah. Thanks a lot for your attention first. Who dares asking one question at this very late time of the day? On this very first intense DevOps day.
It's the last minute between beers.
And there's not a session afterwards?
I'm not sure, but that's time for beers.
Well,
perhaps we have been clear enough. If you want, I don't know, but I don't know you, but I got stickers. Pretty cool stickers like this one. So
go to the
feel free to come and ask yours.
Go to the Google booth tomorrow. We've got plenty
you got a booth.
swag.
I mean, you're cheating.
Come on.
Okay, thank you very much.
Thanks a lot.